2, evaluating from the beginning of the year, is putting everything in where these are. So -7 in for M, 2 in for N. So we have 4 times the absolute value of -7 minus 2. If you're doing this by hand, you would do what's inside first. So 4 times the absolute value of -9. There's nothing else left to do on the inside, so the absolute value bars would drop. This would become a positive. So this would be positive 36. Questions on that one? Number 3, this is going back to our polynomial operations. If we're finding area, we have to multiply these two. So 2y times 3y minus 5. Distribute the 2y. The 2 times the 3 would just be 6. Because we're multiplying like bases, we are adding our exponents. And then this would just become -10y. If we knew what the actual value for y was, we could find the actual area, but we don't, so that would be our answer. Questions on that one? Okay. Take out your pink sheet from last class. It'll be a good reference for you today. If you didn't finish it, you'll have to do that in your own time. And then while you're doing that, pass up your SharkBite answer sheets. Make sure your name is on it. So I'll just collect them from the front tables. Page. And to think back to our domain. What is the domain? What does it refer to? What are we talking about when we're looking for domain? The x values. What are some other words that we can interchange with that? Input. And there's something else. Go ahead, Victoria. Independent variable. And then your range would be the opposites, so your y values, your output, and your dependent variable. Okay, so last class was like the exportive version of our domain and range. Today we'll just be taking some notes on it. So we didn't talk about these vocab words specifically, but we were doing these examples. When we found the domain and range before, we were looking at 2 different types of graphs. So the very first time we were doing domain and range, when we were doing relations and functions, those were discrete because they were graphs that had like a bunch of ordered pairs. They weren't connected. And the ones we were doing last class were continuous. Because they were like lines that connected. This piece of information we'll fill out, not this part, but we're not really going to talk about that today. That'll be a next week thing. So a continuous function may have points when the function crosses or touches the x-axis or y-axis. When this occurs, the function has a y-intercept or an x-intercept. Disregard this part for now. We'll go more into depth about that part later. So we're just going to do some of these examples, and then any you want to see, and then I'm going to show you something on for one of your Khan Academies, and then you'll have time to practice. So let's start with this first one. Here, is this a discrete or continuous function? Anna? Mm-hmm. Because the points aren't connected. Don't connect them. They don't need to be. Now, you need to know the difference. You don't need to write it. You'll need to know how we write the domain and range for the different graphs. So for our discrete graphs or functions, we list them least to greatest like we did before. So look at your x values. How would we write our domain least to greatest with no repeats? What do we think? What would that be? What are our x values least to greatest? Alex. What are our range values least to greatest? So if you don't have a continuous function, you should be just listing out the numbers. Because if I said this was from -4 to 3, that would not be true. There aren't points in between here that are part of your x values. Just the specific points. Is this a function? Yes. We don't have any repeating x's, so yes, that is a function. Right? You may be going between the stapled and the individual sheets for these because they printed weird. If you want to staple them all together, you can, but they're out of order. Find example 2. I think it's in the, not the packet, but the sheets on your desk. This function is discrete or continuous? Continuous. You can tell because of the lines. So again, you don't have to write this, but you do have to know the difference. So for our continuous functions, we're writing them as we did last class. The curly brackets, x such that, y such that. Because we're not using the foldable, if you wanted like blockers to look for the lowest, highest, furthest left, furthest right, you could draw in lines. So look for your furthest point to the left, furthest point to the right, furthest furthest lowest and furthest highest points. That might help you see, like, similar to the foldable. So what is your furthest point to the left?
-5.
-5 for left. 4 you were thinking highest or right. So -5. How do we write this? What comes next? Alex? You're close, but less than or equal to. What goes next? X. And then less than or equal to again. What is our furthest point to the right? You guys are like whispering at 6, yes. And then curly brackets. And then for our range, what is our lowest? S, -3. Help me write this. Matthew?
3 less than or equal to 2.
There's pieces missing. -3
Y.
less than or equal to y. What's the rest?
Less than or equal to 2.
And the highest point, is it 2?
It's 4.
It's 4. So be careful with that because sometimes there'll be multiple points. Always look for your highest, even if there are 2. Is this a function? Yes. If I draw in vertical lines, it doesn't cross anywhere or repeat anywhere. That was supposed to be a circle, it wasn't really. Sure. Questions on this one? Find example 3. This was supposed to have here. If you look on your reference page, there should be an example or 2 very similar to this. The difference is this has a grid, that one does not. For your domain, remember that this keeps going down and slightly left, and this keeps going down and slightly right. This is continuous, so we're still going to write it like x such that, y such that. If this keeps going left and right for our domain, what would our domain be? Look at your reference sheet. Look at examples similar, Hannah. X is an element of all real numbers, but how would we write that? We can write X E R. For our range, let's do this real quickly. What is our lowest point? Do we know what it is? No. What about our highest point? 3. So if it's everything below 3, how would we write that? Nature? Just like that. Alright, we'll answer if this is a function and do more when we get back. Oh, was that a function? Yes. Okay. The next one. that looks like this. It might be in the packet, I don't know. The pages are numbered at the bottom, so page 5, wherever that is. Okay. For our domain, what is our furthest point to the left? Do we know what it is? What about our furthest point to the right? Victoria.
Is it the XER one?
Because it keeps going to the left and the right. For our range, do we have a lowest point? Yes, what is it? -6. So does it start off? Nope, I'm gonna have you guys tell me. What's the highest point? -2. So how would we write our range? Victoria, go ahead.
-6 is lesser equal to y, which is lesser equal to -2.
So sometimes they'll be different. Like one will have something to do with arrows, and one will have technically this has endpoints, but not at the same time. So it really just depends on what the function or graph looks like. Is this a function? It is on the sides, but it's not in the middle. Okay. Questions on that one? All of these examples, hold on one second, that say x-intercepts and y-intercepts, we're going to come back to that next week. Alyssa? We're looking at our lowest point to our highest point. Lowest was at -6, it does not go past that. Highest was at -2, it doesn't go past that, so it'd be everything in between there. Nature? Oh, technically it is a function here and here, but not right here. So because of this, the entire thing is not a function. That's it. Anyone else have a question? I feel like there was another hand. Find the example that looks like this. I think this is page 6. Looking at your domain, what would that be? Because this keeps going to the left, keeps going to the right. So, curly brackets x such that x is an element of all real numbers. Ooh, that was 2 new lines. Our range, what would that be? Do we have lowest and highest points? Do we have arrows? Nature? Does this keep going down and keep going up? Alex? 4 is the highest, yes. Cameron?
Is -4
Yes. I chose one thing. So this between those two numbers, how would we write our range? Lily? Would this one be a function? Yes. You do your vertical line test, it doesn't have more than one place anywhere. Last one. On page 7, this example. So this is very similar to the one we did where it was like a straight line for our range, but now it's opposite. Is our domain moving at all? No. So it's just at one place. How would we write that? Go ahead, Alex. That would mean it's moving up. So something about 2, but not less than or equal to. Iman equals. So if it's just a straight line, whether that's horizontal or vertical, it's just equals. It's not moving anywhere else. What would our range be? Nature? This one would be all numbers, yes. I don't know why I wrote it like that. Okay. And then is this a function? No. It is a vertical line itself, so it can't pass the vertical line test. Look at all the other examples we did not do. If there are any you see you want to go over, have questions about, want to see, let me know. Circle. The circle one. Cameron, this one? Yeah. Mm-hmm. Lily? This one? That? That might be the exact one, but it's a little different. Anyone else? Cameron?
I'll give 6.
That one at the top. On the left. Lily? Any others? I think this is a good list for now. Let's start with the square on page 3. What's nice about this is because it is a box or a rectangle, you can easily see the furthest point to the left and right, as well as the furthest lowest and highest points. Because it's not going to go past those. So what would our domain be? So look at furthest point to the left, furthest point to the right. Tell me how we would rate that.
Would it be 4 or
For the furthest point to the left, it would be at -5. 4 would be your furthest point to the right, though. So how would we write that? Nature.
The curly brackets move x such that at -5 is less than or equal to x is less than or equal to 4.
And our range, how would we write that? Look at our lowest, look at our highest. We have endpoints, so they're going to look similar. Alex?
Curly brackets y, -5 less than or equal to y less than or equal to 6.
Is this a function? No. It literally does not pass the vertical line test anywhere. Questions on that one? Our next one was this page. On page 6. What is the domain of this function? All numbers. And the range. Say it again. Because the arrows are going both up and down, so it's clear to see for the range, but imagine that it's also going up and left and down and right, so left and right as well. Is this a function? Yes. The next one on the last page, page 7. What is the domain of this? Victoria. All row numbers, XER. Wow. What about your range? Victoria. Y is an element of all row numbers. Is this a function? Yes. The one right next to it has endpoints. So we can find our furthest point to the left and right, as well as our highest and lowest points. What would our domain be? Where does it start?
0 is equal is less than or equal to x. X is less than or equal to 5.
And for our range, what would that be? What's funny is he walked to the door and then saw I was up here and then walked past and then walked back and then knocked. I was just like, okay. What's our range for this one? -3 to what? Is this one a function? No. Questions on that one? Yes. Yeah, it's 0. It starts at 0 because it's on the y-axis. For the circle one, this also, much like the rectangle, has endpoints. Just find where the circle stops. Not all the time if you saw circles, but I think that these are the same values. What is our domain? Go ahead. And then our range. What would our range be? It goes to 7, yes, and it starts at so it ends at 7. Where does it start at? I didn't hear that part. What number did you start at?
7.
That's where it ends. So what's the lowest point?
Wait, is the highest the lowest? Or
It's
lowest?
always lowest to highest.
So -1.
Okay. That was the number I didn't hear. Is this one a function? Correct. So I'm going to show you a couple on Khan Academy. One of them is your given graph, so that one you should be able to do. Just make sure that you can tell the difference between the discrete and continuous functions. Hold on 1 second. For this one though, to determine the domain, you need to use Desmos because we are not looking to do domain algebraically. That's for later time, later class. So you can put this function into Desmos, not the g of x or whatever it says over there, just the actual function itself. So 5 minus 2x. Zoom out, see if you can see endpoints. If you get to like really large numbers and you don't see endpoints yet, it's not going to stop. What you could also do is the numbers that they give you, 0, 5 halves, you can graph those. X equals 0, x equals 5 halves. If either of these lines touch your original, they are part of your answer. So they are not, it wouldn't be the not equal to. Both of these are solutions. It's going left, it's going right. So this one would be all row numbers. I might do this again to show you one other example. So for this one, the square root of x minus 10. There we go. So again, zoom out, see if it ends. These are getting big, so it's going to keep going to the right. Find where it starts. It starts at 10, it keeps going to the right of that. Which of these answers match that? That it starts at 10 and it keeps going to the right. Nature? So all of your square root equations are going to be, or functions are going to look something like that. You could also put these in just to make sure. So at 0, it's not touching it at all, but neither is the rest of the function. So it has nothing to do with 0. At 10, it's equal to 10. So it wouldn't be the not equal to, but it only goes to the right, so greater than. I'm going to do this one more time. Sure, one like this. Any one that's a fraction, still put it in, see what happens. X minus 3, x plus 2. It'll look weird, like this. Put in the two numbers that it says. So -2 and 3. And see the one that touches your graph is not going to be part of your answer. The one that doesn't touch the graph at all will be part of your answer. If you look at this, it looks like it's going to touch it, but if you zoom in really close, they're not actually touching. So it's not going to touch it anywhere on that, whatever that line is. Was that -2? Yes. So you can use that to help you. Do we have any Khan Academy questions? So the other one you're given graphs, so you don't need Desmos, but for this one, use Desmos because it'll help you. For the remainder of class, you could be working on these things. The rest of the practice problems and the notes from today all of the Khan Academy that is due tomorrow. So if you didn't do the one I had you do in class 2 classes ago, that one. The 2 on domain and range. After you've done all of that, if you need to work on your test still or retake work, then you can do that after those are done. Let me know if you need my help, have questions.